As another example, let's consider heat transfer, where the heat gained I can't spell, gained by one substance is lost by the other. So let's say we have 100 grams of iron metal, and say it's pretty hot, say 500 degrees centigrade. We're going to drop this in water. So we drop it in 1,000 grams of water at 25 degrees centigrade. So heat is going to flow from the hot iron into the cooler water. So I want to find the final temperature of the iron and water once the heat is transferred. Okay, to set this up, we have the heat gained by the water, so we use a positive sign since heat is gained by the water, is equal to the heat lost by the iron, and we use a negative sign to show that heat is lost by the iron. So we have the mass of the water, specific heat of the water, times the temperature change of water, T final minus T initial of the water, is equal to negative mass of the iron, specific heat of the iron, times the temperature change, T final minus T initial of the iron. Now T final is going to be the same for both the water and the iron once all the heat is transferred. They'll equilibrate to the same temperature. So that's what we want to find. Setting up this equation is easy. Right here, we just have to make sure we get our signs right and then substitute in for MC delta T for Q. So now we have to just algebraically solve this equation for T final. This is a good practice for algebra. So for me, it's easier to break these factored terms up. The T final minus T initial is factored out on both sides. So break those up by multiplying through. So I have mass water, specific heat of water, times T final minus mass water, specific heat of water, T initial for water, and that equals negative mass iron, specific heat iron, T final, and then I have minus a negative mass of iron, specific heat of iron, T initial of iron. Two negative signs here. One comes from the T final minus initial, and the other negative sign comes from negative Q. I'm going to collect all the terms with T final in them. So I have T final, and I'll factor them out while I collect them. Mass of water, specific heat of water, plus mass of iron, specific heat of iron, and that equals to mass of water, C of water, temperature initial of water, plus mass of iron, C of iron, specific heat, the initial temperature of iron. We'll isolate T final by dividing through by everything that's in parentheses on the left side of the equation. So I'll have T final is equal to dividing through everything in parentheses. Okay, so that was my algebra practice. So now I'm ready to plug numbers into this equation. So T final is equal to, mass of water is 1,000 grams. Specific heat of water is 4.2 joules per gram times degrees centigrade. The initial temperature of water is 25 degrees centigrade. Then the mass of iron, 100 grams. And the specific heat of iron, 0.45 joules per gram times degrees centigrade. I'm already out of room. Times the initial temperature of iron, which is 500 degrees centigrade. Then divide all of that by mass of water, 1,000 grams, and its specific heat. Plus mass of iron times its specific heat, which I found from a table. And then doing this on my calculator gives 30 degrees centigrade. So dropping a hot iron block into water only raised the temperature of water 5 degrees centigrade. Now you can see why water is such a great heat sink. Because it can absorb a lot of heat with its temperature only going up a little bit.